Yep, start recording. Beautiful. Yes, the slides should be a memory jogger for you, but I'll talk about the packages that I have in my schema, and also I'll show you the packages that Oracle has. And we'll talk about specification and body, and I'll illustrate that point. So I don't think we'll have a full lecture, but we'll see how we go. Okay, what is an Oracle package? Sorry?
Can I make the folder available to them?
Folder, it is available, isn't it?
No.
Sorry, I forgot. Yeah, please. Oh, I forgot.
No, I thought you were going to pronounce it.
No, I was playing with it last night and I obviously forgot to turn it on. Damn, sorry.
No, that's fine.
Somebody send me an email or something, will you? Put a post on UTS Online. I've got lots of things to remember. Oh, goodness me. Packages. What is an Oracle package? Describing packages, which means that when we talk about packages, we are talking about specification and body. You'll be creating two separate files, a package specification and a package body, and that will all hopefully be clarified for you very clearly, or as clearly as I possibly can. Working with package data, which is global data, encapsulation, and the scope of data definition. And security, which is the hiding data behind package modules. In other words, so far you're used to doing a select statement against a particular table, but it may very well be likely that when you go to certain organisations like your tax department and maybe your banks and so, table data a lot of times is not available to you because of security, and you might have to have certain clearances or whatever to see data. Yet you have to write the code, but what they do is they'll release some code, which will be a package, whatnot, to allow you to extract the data that you need to see, which means that they can control it. So we can basically, from a security point, we can hide data access behind package modules. And again, from the package, we can control what's public and what's private, and those terms should be crystal clear to you from the Java days. What is an Oracle package? I'll sort of skim this thing through this very quickly, and by all means, feel free to Google Oracle packages. Yeah, you'll get a lot of this same information. A package is a grouping or packaging of PLSQL code elements. When I say elements, procedures and functions, and type definitions, data definitions, and so. Packages provide a structure in which you can organize your programs and other PLSQL elements such as cursors, types, and variables. They also offer the ability to hide logic and data from view and to define and manipulate global or session persistent data. Hopefully I'll explain that as we go on too. I'm asking a question, does this sound familiar to you guys? They should be straight out of the Java or object-oriented paradigm, I suppose. Not Java, but certainly object-oriented. It was and still is the case. No, I don't think it's still the case, but it was a case that packages were not well understood by developers. Therefore, they were the most underutilized feature of PLSQL. That's not true. Now everybody writes in packages, and any Oracle developer worth his salt works with packages, as I'll show you in the Oracle database. This will not be, well, if that is the case, that it's not well understood, this is not going to be the case anymore, because well-trained developers like yourself will be entering the workforce, and you'll be understanding these things. In some other languages, the packages may be equivalent to a library in C, and what are they, classes in object-oriented programming and so on. So it's a sort of similar concept. Why packages? A package should be a cornerstone of any complex application development project. But remember, a package is not something new. It is a collection of the modules and variables that have been discussed so far in this subject, particularly procedures and functions. And we spoke about types and so on. The advantages of using packages are easier enhancements and maintenance of applications. Code can be written once and reused by many applications. And logically related functionality can be grouped together. So if we have file operations or email operations, we will generally put all those methods and procedures that refer to file operation in a single package, as opposed to writing many different functions and procedures that we don't know which belong together in a group, if you like. Improved application performance because when package loads into memory, it stays in memory until such time as the session ends. You log out or the system logs out. It is easy to overload weak functionality in existing packages. That's the benefits of packages. What are the package concepts? Here are some of the concepts that make packages such valuable tools. Many of these concepts should sound familiar from object-oriented programmers. Information hiding. Information hiding is the practice of removing from view information about one's application. You only expose to the user or to the reader the methods and modules that you want to expose. Everything else is hidden in the body. Hide the complexity and the low-level detail. Security. Not everybody should be allowed to see or know the details of an application or business rules. A function call is made visible to retrieve the desired data. Public and private. So we've got information hiding. We can hide information behind code and then give access to code. So you basically call some method or procedure, and then the data that you want is given to you without you having access to the raw data in a database. Public and private, closely related to information hiding, the concept of public and private. Packages are built around the concept of public and private elements. And when I talk about elements, I'm talking about procedures, functions, and types and data types. Public. Code and variables are defined in a package specification. Remember this word, specification. And are available to any schema that has execute privileges. So you guys have your own schemas. I have given you execute privileges to run my common.log. Common is the package name. Log is the module inside my package, as I'll show you in a little while. Yeah, public code is very defined in a package spec. So anything that you want public is defined in a specification, which I'll demonstrate soon. Private code is defined in and visible only within the package body. So we need to define some code or some modules that we want private to our application, then that is defined and written inside our body. What we want the users and other programs to see or visible is defined in a specification, and whatever is defined in a specification must be implemented in the body. So if I define a module, a procedure called log in my package called common, that log I define its signature. Now remember last week I spoke about what signature is. The name, the data coming in, and the data that's being returned. That's a signature of a module. So that the signature is defined in a specification only. The signature, sorry, I'm using the words wrongly. The signature only is defined in a specification. And in the body, we implement the signature. We implement the code. We write the code. And because it's defined in a specification, by the virtue that it's in a spec, it's public. So you can call common.log, public, you can see it. But log may be a procedure that could call other procedures inside my package. And if those procedures are not defined inside the specification, you don't see them. But log does, because the system owns that package. So I expose one little part to you or to the user, and then that little part, I control what you can do, or I control. Well, the developer, you control what you can see and the sort of data that you have access to. Private code is defined and visible only from within the package body. So I'll show you all that stuff. The specification, I've explained all this, so I won't go through it again. I spoke about the signatures and so on, and the body is, so we're in the package spec, and this will be much clearer once I show you an example. The spec, we define variables, which we might potentially call global, variables, types, and modules. that we want to make public. We define them in a specification. Define in this situation means we only write down their signature, and the package body then implements that code. So I don't have to go through that again. Initialization. When a package is called, the concept should not be new to you, I believe, from object-oriented. The package specification can contain initialization code that will be run the very first time, and I use the term the very first time a package or a bit of code is called, I call it touched. As soon as that code is touched, right, you call it for the first time. That first time you could potentially run some initialization code, set up some variables and do whatever. Then potentially, and of course, once that code is touched, it's loaded into memory, into buffer, and then as your code runs and you call in the services of that package, you can call other modules as need be, but the package may very well be initialized. All the initialized values are sitting in memory now for you. You don't have to go through the database and so on, or whatever you decided to do. Oracle, and once the package gets loaded into memory, it doesn't have to get reloaded into memory again. With procedures and functions, or standalone procedures and functions, each time you call them, they basically get loaded from disk into memory to run. When it's finished, the system basically destroys them again. Oh, when I say destroys them, destroys that instance of it in memory. Oracle guarantees that the initialization code will run only once. Whatever the initialization code that you have, and it's optional whether you have it or not, Oracle guarantees that that initialization code will only ever run once. Like that code wouldn't be repeated again. Can run code that initializes the state of the package. And session persistence. When you connect to a database, you establish a session. Now, you saw me last week when we spoke about exceptions. You saw me, transaction management, and Harry was at the back. Good on you, Harry. Thank you. Harry was at the back doing select statement. He had a session. I had a session. But you saw me also create an exact same login with my user ID password, and that was also a separate session. So when you connect, when you log in, you establish a session. That session is current only until you disconnect. So whether the program is running by itself or you connect, when there's a connection made into the system, that establishes a session, and it's in that session that we initialize and do whatever we need to initialize. Once the program is finished or you log out, that session finishes. And if you have multiple logins with your code, or multiple occurrences of your code running at the same time, there's separate sessions, which is a real adventure in a database environment, particularly if you're updating and loading data. You have to be very careful you don't clobber each other and lose things and whatever. Because remember, your one code is running potentially multiple times in different sessions. Yeah, so there's this concept of your own session, but sometimes you may ponder, and you don't have to give yourself headaches about this in this subject, but think that your program might be running multiple times, and they're multiple sessions, and what they're doing and what's happening. Here, and me saying that, here I am telling you that in your assignment, and certainly in the tutorial, your program should only ever run once. But that's the nature of that program. You could write a program that could multiple sessions could be running, or the same program could just be constantly running and being called, or by different applications and so on. So again, I think I've hammered the session concept long enough. Variables that are initialized in packages retain their value for the duration of the session. This is one way that you can pass values from one application to another. Now, that's a very important concept, because up to now, I've spoken in different contexts about variable scope. Then I sort of spoke, your variable scope, we spoke about blocks and how the scope of a variable defines in a block. I showed you how I could pass a value call a procedure from a procedure. I could call another procedure and maybe call another procedure, and I could pass those data types across as parameters to different procedures. But it's possible for us, and tonight's lecture that was supposed to be on, we could define our own data types and our own collections. Substitute word array if you like. We can define our own data types, and in one session or one module, one procedure doesn't know about that data type to the other one. So it's difficult to pass those sort of data types across. But in our application, because the session is current, the system will know the data types because we define them in a package, and those definitions are current in that session. So as we pass information from application to application, we can pass complex data types if we need to. You won't have to do that in your assignment. It certainly won't be that complex. But these sort of things happen, and you see a lot of these things, the way that people make it all work and so on. This is just a diagram, and I hope I've explained this diagram already clear enough, but this is your spec and this is your body. So what's inside a body is only visible within the body, and what I'm basically describing here is that this is your package. There is a body inside the body, and what's defined in a spec is what's visible to the world. There are outside programs or modules or whatever, SQL statements, in my case, as I've explained to you, that are calling onto the services that you provide inside your package. And you expose it, or you open those services to the world by making them public inside the package spec. So we can call those methods or modules from any other program outside, and those modules can call other modules within the body that are not made public to the outside world. So we expose what we need to expose, but the public modules can certainly do have access to the modules inside the package body. What I find in the assignment too many times is that students tend to, every module they have in the body, they put into the spec. And I dare say that those students, when they write Java code, or I shouldn't concentrate on Java, object-oriented code, they will probably, their method definition will be public, blah, 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 public, blah, 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 public, blah, 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 public, blah, blah, blah. That's how they think, and you can't change them. Yeah, but what I would, and I will mark you down if you make everything public. Now I've gave you 3 or 4 different package methods that I wanted you to run the settlement in the assignment. I wanted you to run the report, and I wanted to be able to run it independently. And obviously those methods are to be called from outside, whether it's SQL or whatever. They obviously have to be made public. But how they do their job, and if you're a good developer and you're a conservative developer, you would expose that method and maybe not put any code in there, but just simply a call to a private routine. How you do that, that's entirely up to you. But anyway, this is a sort of a schematic example that you might have many procedures, procedures and functions inside your body, data types, data definitions, complex data types, and so on. You expose only certain modules. Those modules, because they all belong in that package, they have access to all those services. I'm using all the wanky words. They have access to all the procedures and functions inside the body, as well as the data. Inside the body, all these procedures and functions have access to each other, and I'll talk about this. I have something to say about that. But from the outside, the external programs, your SQL or other code or other developers that write code, whatever is exposed. Public, private. And whatever's public, basically all these modules have access to the package data. Referencing now, once you write a package, the way that you reference your data is basically the dot notation. Package name, If you have a procedure, package name dot whatever. In my example that you've used so far, common dot log. Common is the package name. Log is the module name. The way you call that is common dot log. Parameters, what data you pass in. If you define types, remember we came across the percentage type. Well, when we talk about collections and records, when we come back from holidays, I'll show you how you can define your own complex data types with a type keyword. And now we use percentage type to sort of bind that to maybe an attribute in a table or maybe even a cursor or whatever. But we'll be able to create our own types. And then once we create our own complex data types, we could then refer to that in a package name dot type, if we make it public. And this is how we will then create, we would infinitely enhance the scope of our variables. So we define variables in certain areas. We might have a package called standard. And in that standard package, we will define variables that we use in our organization. So we don't have to continually redefine them in different applications. We define them in one place and then access it through the packages. The way we access them, package name dot, if it's a type. If we define variables inside a particular package, package name dot variable, package name dot program, procedure or function or whatever. And again, so you were told, I think in your assignment, your package is going to be called PKG underscore settlement or something. And then your methods that I want you should call is settle transaction or settle, or I forget what it is. So basically I'll type in your package name dot settle, and I expect the system to say go away and do something. If it comes back and says program not found, -10. For stupidity, if no other reason. So please understand that. And it's the same as your object-oriented stuff, so it's not hard. Working with package data. Package data consists of variable and constants defined at the package level. The scope of the data is then the whole package and not just a single module. Because when I say the single module, when we spoke about procedures and functions, I showed you how we define variables in the underneath the creation. We have to define variables first, and then we use them through the method. If we define variables in sub-blocks, then the scope of that variable is just that sub-block. Remember all that, it's academic, but, there is some value in it. What we are going to be doing is we are going to be, in the packages, we are going to be creating variables depending on what level we create them. If it's at the high level, the variables are then visible to every module inside our package. If we define variables inside our spec, then the variable is visible to any piece of code that's sitting in a database. You could set its value in the package. You could set its value and use that value as your other programs run for the duration of the session. But again, this is best explained with examples, which I will do. The scope of the data is then the whole package and not just a single module. In the PLSQL runtime architecture, package data structures persist for the duration of the session. I'm saying the same thing over and over. From the time you log in to the time you log out. Public package data is very similar in functionality and as dangerous in use as global variables. So again, I hope that in your programming training you've been told to be sparing with your global variables. I hope they still teach you that, because global variables are dangerous. It makes you lazy, and it's too easy to clobber information with, particularly if you've got multiple sessions and things running. So global variables are, I hope they still teach you that. I don't know if they do or not, but package data is similar in functionality and as dangerous in use as global variables. However, the global scope is the single session only. So once the session ends, whatever values are in there are gone. Implementing security using packages. When a module in a package runs, it does so with the same privileges as the owner of the package. Now listen to me. Let me say this again. I am DBP_admin. That's my user ID. Yeah, I have some packages, and I create a package. Yeah, and which is in our case it's common.log, and I gave you execute privileges. Yeah, so you can run that package seamless to you. You don't really care. There's this concept of everything is owned by a schema. When you create your tables and you create your programs and you create your procedures and functions, your owner ID owns that data. DBP_admin, I have a lot of tables that I have given you access to. I've given you select privileges, but you can't change that data. I haven't given you the privileges. Yeah? When my package runs, when your package runs and your code runs, it runs as you. But when you call a module in my package or somebody else's package, that code that runs with the assumption that the owner is the user ID that created that package, even though you're running it. So in the code, if I'm running it and I'm calling a service of a package owned by system, for argument's sake, and that package has a routine to delete data, you might not have the privileges to delete the data, but because you're running the package is running as if it's the owner of the package. Yeah? So if I have the privileges to delete data, you call a service to delete data, the package will delete the data. If I knew the table and if I had a statement, SQL statement that says delete from order table in my package, it won't happen. But if I have a service in my package, common.log, I say, delete order. You might call that, the code says delete order, the system is running as the owner of the package, even though you're calling it. You understand? So your session, you're the owner, and you have those privileges. If you call the services of a package, the services are being performed as the owner of the package. And of course, I can control that because when I write the code, I'm controlling what I can, I don't blatantly give you access to delete data unless I do a hell of a lot of checking beforehand. This gives you the ability to hide a table from the user. Access to add modified data in a particular table is done by calling the appropriate package module and passing parameters to the module. Values can be checked and data modifications can be controlled. So in our parameter table, I keep telling you all the time, look, we're going to put parameters in. The system might own that parameter table. In your case, it's you. And you might write your user a GUI application where they can change the value. Yeah? And so they change whatever they do. They press submit or OK, and the value is changed. Yet, if they go into the database and try to change that data by saying update or delete, privilege is not granted. You understand? That's what I'm talking about. So basically you can control things that not authorized people are doing through code. Yeah? Up to now you're doing select statements, you can select from my table, whatever, but I've controlled everything in SQL. Yeah? So this is what I'm talking about. Code is doing the control. So you're providing a service, user presses the button, does something, delete this, delete order, etc. Everything happens, but you're controlling the code because you are the owner of the system. And this is why when you write application, there's usually a single master user ID for every application, which is top secret. Only a few people know it because it's the user that can control this thing, set things up. Everybody else, don't touch. Security. Security means protecting as well, protecting your data. Packages allow the creation of private modules which can only be called from other modules within the package. This enforces information hiding. Packages allow the creation of private modules, so I can create modules or procedures and functions in my package body which can be called from other modules within the package, so everything's visible to the package. This enforces information hiding. So you don't really have to know things are being implemented. They're being implemented. Collect all your standalone modules. Now, this sort of puts everything together. What I've been talking to you about: anonymous blocks and procedures and functions. Yeah. Always construct your application around packages. Avoid standalone modules. Avoid procedures and functions. Avoid standalone procedures and functions. Even if today you think that only one procedure is needed for a certain area of functionality, in the future you will almost certainly have 2, then 3, and then a dozen modules that do something similar, at which point you will find yourself saying, oh, I should really collect all those modules, put them together into a package. That's fine. Now you're thinking, except that now you have to go to the trouble of creating the package. No big deal. By including all the modules in the package, fine. I hope you can find them all. Make sure that everyone knows of the changes that you are making. Now you need to change code that potentially was using standalone modules. Then locate all those invocations of the modules, make the changes, and add the package name prefix to the module name, assuming you've called a name. So all that, eventually you might get that to work, but then you have to test the whole bloody thing. So you've started with something simple, one little module here, one little module there, you create something, then all of a sudden you might say, oh look, we should really put all this together. This used to happen a few years ago. It certainly wouldn't happen anymore. It would have been much simpler if you started with a package. Note to Laurie's class, from now on all the code you write will be contained in a package. I don't mind you writing anonymous blocks, I don't mind you writing procedures, I don't mind you writing functions. In your assignment, if you write any code in a standalone module, I will not look at it. Yeah? And often when I look at your package, when I look at your code, it takes me a while to click onto it, but if I see standalone modules, not accepted. Understand? Do I get a yes? I see a thumbs there, but I haven't heard anything else. Understand? No standalone modules under any circumstance. For no other reason than to try to enforce some habit. When you leave the subject, you do what the hell you like. Guidelines for writing packages. When writing packages, keep them as general as possible so that they can be reused in future applications. And for this, I have to say to you that you may, when you write your package, your package for the assignment will be written in the context of settlement, yeah? But you will probably do a lot of stuff in your assignment where you're checking, updating, retrieving data from parameter tables and, where management things are happening. Management things that potentially, if you're writing multiple applications, you will be repeating in the package. If you find that you're repeating that code, bad. This is where it would be wise to potentially write your package to do a job. But if you have management tasks and you need to initialize systems and do whatnot, it's quite acceptable to maybe have a standard package. So at most, you will maybe, for the assignment, it will be trivial, but you may have 2 packages to submit. One is your settlement, and the second one is that you want to divide your administrative tasks into a separate package. That will be fine, but, it just means more work for me. But as long as you walk away thinking that, because in workplaces, there are hundreds of packages, and I'll show you in a little while in the database, and each is basically designed to do a specific tasks. And maybe that task is broken down into multiple packages. I'll have a little bit to say about those multiple packages and whatever. But at the moment, this is the guideline that I would like you to sort of think about. Package specs reflect the design of your application. So the specs will reflect the design. This is what it's doing. You're exposing to your user what the package is doing, so that you're exposing those things into your to your user in a specification. 1, create desk bank file. 2, create a desk bank report. 3, create a terminal usage report. That's the 3. That's your design, yeah. And how those 3 processes work are then, you branch off in your design. The users don't need to know about the details. They just need to know create desk bank. How that's done, that's private. Yeah? So the design, the high-level design, is generally reflected in your spec with modules that you initialize or sort of start up to start the system. So define them before the package bodies. Place in a spec only the types, items and subprograms that must be visible to users of the package. That way, other developers cannot misuse the package by basing their code on irrelevant implementation details. So in your design, you should be now starting to get, like somewhere, there's all the little cartoons and everywhere where ideas are floating around people's heads. You should be getting, okay, I've got a desk bank file I've got to create. I've got to create a report. But how do I create a desk bank file? So there's all these modules. This is in your mind, you're designing the system. You're building the system in your mind. So those will then convert into modules, I suppose, if that's how you work. To reduce the need for recompiling when code is changed, place as few items as possible in a package spec. Changes to a package body, changes to a package body do not require Oracle to recompile dependent procedures. However, changes to a package spec require Oracle to recompile every stored program that references the package. Now, that's a lot of words there, but what it means, if you compile a spec, then every module that your package calls on, Oracle recompiles those packages and modules, even though they're not yours. So every bit of code that's being used by your package gets automatically recompiled, including packages and modules that are not yours. But when you compile the body, it's only your body that gets recompiled. So what you should be doing is that you should have a high-level design of your system. There are 3 modules that you need to expose and make public. Maybe you could want to make another one, but I can't imagine it'll be any more than maybe 1 or 2. You create the spec, you compile it, and that's it. You leave it, and then you work in a body. All right. So that built-in packages supplied by Oracle. I'll show you a bit of that. The Oracle database provides a rich set of packages that can be used for different types of applications. The bulk of the functions that are used in SQL are stored in a standard package. You have been, and of course that's hidden from you. You don't have to say standard dot because it's all been made transparent. You have been using the built-in package extensively. DBMS output, it's a package. DBMS output.put line. And we'll have a look at this in a little while. Later I will show you how to use the UTL file package. UTL file package is to write into the operating system file. Your net utilities and so on. This will enable you to write output into a Unix operating system and so on. So we'll talk about that. Now packages are defined by the package specification and implemented by the package body. Packages give the developers the ability to group logically related functions, procedures, global variables, and cursors. Your assignment is one logically related application. But in a real world, you could be writing hundreds of different applications, and they would have different packages. In a lot of the situations, packages improve the performance of your application because the code is loaded on first call of the package. The first call is expensive, but subsequent calls are virtually free. Packages can be used to implement a level of security by allowing access to table data only by a call to a package. Beautiful. Now, I'm going to show you some packages, but I want to talk to you about something. And I sort of touched on it briefly when I was going through the lecture slides. I said you should put everything into one package. Consider in a workplace. Consider a situation where we have 10 developers working. Now, what happens when a developer gets the code? What happens? You get given the code and you make some changes and you get whatever. Is it feasible for a piece of code to be given to 2 different developers? You'd have some fun if that happened, wouldn't you? Because one would be clobbering the other one. Yeah? So there's this problem in environments like this is, sure, we group everything together, but that means only one person can work on that part. So what do we do? How do we do version control? How do we manage all that? That's not a topic of this discussion or this subject, but something to consider. For your assignment, you'll write one package. But consider in your development, education and whatever, it's all, people talk about version control and so on. That's fine. You've got one package that does settlement. We want to put 3 people on it. How are we going to do this? It's on a one machine. We compile. It compiles all into the one package. Do we divide it out? What do we do? It's a problem. It's a major problem. So when a development team is put together and your team leader, your programming team leader is there, that's one of his problems. He's got to work out how the hell is he going to divide the code and so that it doesn't get clobbered. Yeah? Now, not a problem for you, but just consider that little thing in the context of what I was talking about. I'm going to take you now into my schema, which is DBP admin, and I'm not sure if you can see this or not. And I'm going to show you what a package looks like. First of all, I'm going to show you common. Now, common, this is the spec. The code is create or replace package name as, and in that specification, create or replace, you don't say create or replace package specification, you say create or replace package. This double quotes is only SQL developer being stupid. You don't put double quotes in there. You create the package name as, and in here, what you do is you only list the signature of the methods that are public. So I'm looking here, the signature, I have a method called a procedure. The procedure is called log. It takes in a varchar and it takes in 2 parameters, 2 varchars, procedure, that's all it is, semicolon. Its definition. We have another function, fcenter, that takes in a text, takes in the page width, default 80. If I don't specify anything, it returns a varchar 2. That's all. The fact that these are defined in a package spec makes them public. This is now exposed and it's available to you. The package is called common. Right? So I would call them common.log. What does it do? What does the code do? I don't really care. All I have to know is the name, what I have to pass in, and what it returns. That's its signature. That's in any language. Yeah? Generally this is... So, package spec, you only define the methods that you want to expose. And of course, if there's some variables you want to make public as well, they will go into the spec. And of course, when you write the code in your text editor, create or replace package pkg underscore settlement, and then you put down whatever you've designed. They're going to have a procedure, semicolon, compile, done. You have a look on the left-hand side. You'll see package pkg underscore settlement or whatever it's called. Then you create another file, and I would advise that you do 2 files, and then for every spec you must have a body. And this is the body, create or replace package body. You must have the word body. Yeah? Whatever it is, common as, and this is, you just start writing the code. if your spec has a definition for a module log, you must implement its code. It might be null, but you must have the same signature in your body as you have in your spec. Otherwise it won't compile. And this is your procedure. Now the procedure that you have in your body is exactly the same as we've done last week, except we do not have create or replace procedure. We simply say procedure or function. And this is your log procedure, Pragma autonomous transaction, which we spoke about last week, insert into, so when you call common.log, you are passing a text in there, and what I do is I insert into DBP message log and I commit. You call common.log, I put it into the table because you can't put it into the table. And I commit. This commit is only for this procedure because of this Pragma autonomous transaction. Remember? Otherwise, if I put a commit anywhere in my session, that commits all my work, or rollback for that matter as well. I have fcenter, and I wonder what this does. I should have a comment that tells me what this does. The comment should actually be in a spec. I should have a comment in here as to what it does because the spec is visible to public. I'm going to talk about wrapping and hiding your code, but here I've got, let's see, what does fcenter do? This function will return a given text centered on a page of a specified size. The given text will be left padded with spaces to achieve the center. Oh. You know my report, you know when we have the heading of the report and then it comes down, have you noticed how it's all centered? Well, you know what I'm looking for? I'm looking for those idiots that write down, quote, space, 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 daily settlement report. I'm looking for those idiots. Yeah, particularly since I make such a big thing. Because I have a fcenter function. You can write your own. What does it do? Return varchar. So it takes a varchar. It takes the width of a page. If it doesn't give me the width of a page, it's 80. Because an A4 sheet of paper in Courier font, how wide is it? 80 characters. How wide is it sideways? 120 characters. You didn't know that, did you? Do some Googling. But if you don't give me a width, I'm going to specify as 80. Return varchar, text width. Text width is equal to the length of the text that I pass in, divided by 2. Return lpad with spaces, whatever the page width divided by 2 is, plus v text width. So I have the text width, let's say there's 20 characters there. I divide that by 2, which is 10. I got a page which is 80 characters, so I divide that to 40. Plus whatever half of the width here. That's how many spaces I have to put in. And then I return back. So I do an lpad here, bang, and all I do is in my call, when I print a heading, I say fcenter, daily settlement report, bang, it's centered. Yeah? So anyway, I'm digressing from the package. So this is the package, and there's only 2 methods in there. I don't have any variables in there, whatever. But let's see what else I've got. Oh, look, I have a package called FFS settlement. I think that's what you have to create, isn't it? I do believe it is. So you will have a spec with comments to describe what it does. That's good programming, good professional programming. I have procedures, daily settlement, daily summary report, P report date, because I want to be able to rerun it. Terminal usage report. Wow. Public, because it's in a spec. So I will now run the package by saying pkg_ffs_settlement dot daily settlement. Enter. The system will then say, oh yes, I recognize this because it's in a spec. Yeah? And then how is the code implemented? Let's have a look at the body. Whatever's in a spec must be implemented in a package. Or, I'll come back to this in a little while, but what did we do? We did a settle, wasn't it? Daily settlement? Was that's the one? Daily settlement. State the purpose of this module. Author. The module name is daily settlement. Program ID. Announce me. Update new transaction. Settle transaction. Print desk bank. Wow. So my code, what I exposed to the public, all I'm doing is I'm calling other procedures. But those procedures are not public. They're in the body. They're visible to this one. So I'm not writing all this code. I'm just calling modules now. Okay, announce me. What the hell's that? Announce me. There it is. Oh, look, I've declared announce. Well, I'll talk about announce me, but here is the specifications. Announce me. In modules, so I pass a variable in. Destination. Default is T. I guess it's table. I could put in S for screen. If destination T, common.log, else DBMS output. Oh. So what I'm doing is instead of printing all the time where I am, I just run my code, announce me, I'm here, as I'm developing. Yeah? While I'm developing, I'm putting it to the screen. While I'm going through and in production, I may want to log, but yeah. So announce me, then what happens after that? The settle, what daily settlement? We've got upload new transaction. Let's see that. Now, upload new transactions isn't in a spec. Yeah? It's in the body. Update new transactions, and let's have a look at it there. Upload new transactions. V module name is upload new transactions. Begin, announce me, V module name. Insert into FFS daily transactions as select blah, blah, blah from FFS transaction. My table into your table, from my table, where not exists. Selects blah, blah from FFS transaction, whatever. So we're just loading new data. Exception, right to the log table and so on. This code I will give you, because this is the code that you will upload any new transaction when your program runs. So then we do that, whatever. Then settle transactions. Settle transactions is, what's the purpose of the module? Author, date. This is the SQL statement that I showed you. I haven't. Cursor. We're creating a cursor. We're creating the settlement data. We begin. Announce me to the screen, to whatever. For merchant in. Insert into FFS daily settlement, blah, 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 loop, end, done. Settlement done. No testing for minimum amounts and so on. Announce me. What else do we have? And so on and so on. Now, let me not lose sight of what I'm showing you. I'm showing you procedures. Packages and how modules are public and private. Now, note this. Note how here I have a definition for the modules that are sitting inside my body. Okay? Now, I spoke to you already about compilers. And I spoke to you about single pass compilers and double pass compilers. Remember? And I asked you, what's the difference? Does anybody know what a single pass and a double pass compiler are? And you all shrugged your shoulders and had no idea. And I said to you that a lot of systems, PLSQL is a single pass compiler. So as the compiler goes through, it builds its symbol table and does whatever it does. It finds a definition of a module, a procedure or a function. It says, oh, it's calling something. Now, unless the compiler has come across that definition of that module, when it comes to its call, it'll say, I don't know what this module is. Because the assumption is on single pass compilers that you define everything you use before you use it. Now that gets complicated on some programs. Often it gets complicated because you might just put one in there for convenience sake, then a compiler won't compile because it says, oh, I don't know what this module is. But there it is there. I wrote it. The compiler hasn't hit it yet. Yeah? So what we do is we do what's called forward declaration. You don't have to do this, but any module that you write in your package, if you do a forward declaration, then you can place it anywhere in the code. Because the compiler comes across this and says, oh, okay, yeah. And then as you go through and implement the code, you might call that module announce me for argument's sake. And if announce me wasn't the first one, it would fail here. Or depending on where you come in and how the code runs. So this is purely and simply optional, and you put it in here to help the compiler and help you too to organize your code. And that's why you do it. It's forward declaration, so a single pass compiler. Now, a double pass compiler or multi-pass compiler, and please Google this at your leisure. Your compilers, a multi-pass compiler, what it'll do is it'll go through all the code, pick up all the modules and build a table. Then it'll go through the code and then it'll reference its table without looking at the code. Otherwise it would have to go forward. So where's all the code? Where's the code? So it builds, first pass it builds its symbol table, yeah, and then it goes through it a second time and starts looking at the code, but it's checking the symbol, yeah, I got that. Beep, I haven't got that. Fail. Yeah? That's the difference between a single pass. And the reason we put these forward declaration, optional, but the reason we do it is to solve the problem of you putting code where you willy-nilly want to. And without having to worry, because you will write quite a few lines of code. You'll probably write 400, maybe 500 lines of code in your package. And as you start putting your modules in, inadvertently, it's not a big deal because your compiler will say, not found. And you'll go, oh, now I've got to put it here. But just put a forward declaration in there, problem solved. Yeah, that's what the forward declarations are. So, package spec, create or replace package body, 2 files. 2 files. You can have 1 file, text file, and your spec could be defined, then you put a /. So as you run the file, you put a / in there, the system will execute it. Then you put them, so you can put it in 1 file, but I suggest that you put it in a file called PKS and PKB. Package spec and package body. Spec, body. Design your system. The whole idea is, in theory, design your system, how it's going to work, and then put the modules that are public into your spec. Compile it once and forget about it. And then the first thing that you should do in your body is implement the code that you put into the spec. Even if you put down, begin, null, end, like I showed you. Or maybe print. Write yourself a little routine that says announce me like I have. And then you don't have to write DBMS output all the time. You just say announce me and write the text. Then you can comment that out anytime you want. Yeah, that's your design. You're designing the system now. Yeah, so you're working out what modules you need, what module calls other modules, and so on. And then you really, in your assignment, all that you will need in your specification is what I asked you to, the 3 modules that I want to execute, that I want to be able to run. So I want to be able to run the daily settlement. The daily settlement, when it's run, should produce the daily banking summary file automatically, and it should produce the terminal usage report automatically. So when your program finishes, there should be 3 files in the operating system. But I want to be able to manually rerun the reports. And if I manually rerun the summary report, I will pass it a date. How I put the date in there is you don't have to worry about it. All right? You don't have to worry about, is the user going to put the date in the right way? I will call it correctly. Yeah? Because we will generally give them a GUI application to run the report again. We wouldn't expect them to go into the database. Now, understand that? The spec and the body. The other thing now is I want to show you is this. It gets a little bit hairy now, and this is something you don't have to know. It's purely for your own education. I'm now going to go and I'm going to look at a user called Sys. Now, Sys is the owner of an Oracle database. This is the owner. This is the user ID that owns everything. So when you install the database, one of the things that they'll ask or they'll give you, the installation Oracle will give you is the sys user ID, or you might have to set the password. Yeah, and there's another user ID called system, but that's sys is the one that owns everything in an Oracle database. And in that Oracle database, what is provided is the whole system works on packages. Excuse me, I forgot your name again. I beg your pardon.
Miriam.
Help me, Miriam, because I'm looking for a package called DBMS output. Yeah, I'm looking for a package called DBMS output. Is it DBMS? Have I got packages? Oh, procedures. Duh. Now note how many procedures. Actually, while I'm there, there's not many procedures. There are some. Sorry, Miriam. Packages. I'm looking for a package called DBMS output. C, D, E, F, G, H, L. Oh, it should be around here somewhere. DBMS. There?
Yeah.
Yep. So there's DBMS output. This is what you call when you print to the screen, yeah? Now DBMS output is there. There's the spec. This is how the professionals do it. This is Oracle. Oracle supplied code. Blah, blah, blah. Example tells you everything. This is how commenting should be done. We have a lecture on this, not the little breadcrumb comments at the end of every line. Oh, now let's do a loop and all this nonsense that students go on. Procedure, enable, put line. So there's a procedure called put line. DBMS underscore output dot put line. What does it take in? It takes a parameter. Varchar. Look at their ordinary variable naming. Professionals, my foot. Yeah? You're not allowed to get away with this. Yeah? So this is the definition. This is a package, and in a spec, they're exposing what they want to be exposed, what's public. If I now look at the body, wrapped, nor can see. Damn. You know how many times we try to get into this code to see how the Oracle does it? Oh, yeah. So the thing is, but you don't have to see the body. Yeah? All you have to know is what it is and what services are available. So what DBMS output.put line does is basically immaterial to you. You just need to know how to call it. The signature of the method. And how it runs is immaterial. Now, let me see if they've got any definitions. No, they haven't got any procedures. There's one that I want to show you particularly, and we're going to talk about this in another week or two. But Miriam, UTL file. UTL underscore file I'm looking for. Now, note how many packages there are. UTL file, there? Yeah, I did. Look, I'm better than you. Yeah. Sometimes I'm under pressure. UTL file, look, this is the spec. They've defined a type as a record. So it's a complex data type. Look, they're defining exceptions. Because what happens when you work with files, you tend to get a lot of errors. And remember, there's only a handful of built-in exception handlers. So what they've done for us is they've gone through. They've created an exception, which is what I showed you. They're using they're binding an exception to a number. Yeah, they're creating a number, and then they're using the pragma and binding the pragma exception in it. They're binding the number to the exception handler. You see that? So when we run the code, the specification is, invalid path, invalid mode, read error, write error, and then we'll be able to write code when UTL file dot write error, then do something, exception handlers. But, I'm sort of digressing. This is a package spec. And in the spec, what they've done is they're defining types, variables, and in this case, exceptions. There may be some variables. Here's the commenting of what things do. And file open, F open. We'll learn about all this. F open, this method, by the virtue of its definition in a specification, is public. And so on, 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 and so on. So the services of your UTL file package are considerable. We'll be only using one or two methods of this, but that's not to worry. Maybe it's to put your mind into what we're going to do. But again, I'm illustrating to you that systems, even Oracle, implements everything in packages. And as you can see, I'm going up and down to show you how many packages there are. DBMS and so on, there's some naming convention. So there's packages. And what we're seeing is the specifications of the packages. If I go through and try to look at the body of a package, all wrapped. Now, we're not going to wrap our code. Don't get me wrong, we're not going to wrap our code. We're going to expose our code. And in most organizations, your code is exposed. Yeah? If they do wrap it, it's just a case of uncompiling. The term is wrap and unwrap. So 7:30, I'm sort of getting carried away here. I hope that you get the message now. So in the package, let me start again. In the package examples that I've showed you here, particularly with the assignment code, and this is only chunks, empty chunks. There's nothing really happening in here. I've illustrated to you the specification, where you define the modules in a specification, you are virtually making them public. And you only define the public methods in a spec. Whatever's defined in a spec must be implemented in the body. In the body, you can define as many variables and as many types in the body. Those variables and types are visible to every module inside the body. If I were to define in a spec, if I were to define a type or a variable or anything, then that type or variable is visible to everybody. So if I define a particular type or a data type, complex data type, inside a spec here, in my code, I could create that variable of the type PKG underscore FFS settlement dot whatever the data type is. And then if I were to call another module in another package or function or procedure anywhere, I could then, as a parameter, I could take in a parameter of a type which is defined in this spec. So you can see you got that visibility, you got that data type that's now transportable across the systems. Because if you create procedures or functions, and in the procedure or a function you declare a data type, it's only visible in that procedure or function. And if in your package body, if at the body level, the top level, you define a particular data type or whatever you're defining, it's visible to every module inside that body, but it's private to that package. Yeah, spec is public, in the body it's private, and you can use it anywhere you like in this spec. Now the other thing is that I spoke about initialization code. When you run the body, when you call the package, what happens here is that we could write this spec and say something like this. Begin. And this is the end of the package. And in here, we would now execute any code that we would want to run on initialization. Remember I said the first time a package is called, what the system does is it always runs this initialization code if there is any. Yeah? Here we don't have any initialization code, but if we put some initialization code in here, this part of the package will always run automatically and guaranteed to run only once. We don't have it, so it's not an issue. There's nothing that I felt needed to be initialized. and this stage, yeah? But when I talk about initialization code, that's that. Everything else is just procedures and functions. Procedures, functions, procedures, functions, procedures, functions, procedures, functions, procedures, and functions. And again, you, in a body, you could define a cursor or anything else at the top level, but then you're saying, could be asking yourself, is this a good design decision? You know, should you, at what level should you be making things visible to yourself? Especially when you define things in a spec. And frankly, this, I think I'm repeating everything that you've been told in OO. Correct? You're a good OO programmer, are you? Is there anything new that you've learned tonight? Conceptually.
Yeah, it's pretty similar.
There's nothing new. You've learned how to create a package, spec and body, which is slightly different. But that whole concept of, you know, modularization and code and wrapping it all up and, you know, what's private, what's public, this stuff you should be living and breathing in every subject that you're doing. This is not new. Yeah? And again, this is why I'm really surprised that half the bloody class will put everything in a spec, which means they make everything public. So what the bloody hell are these kids learning, for Christ's sake? Yeah? I scratch my head, I just don't know, you know. That's why I sort of don't really know what to tell you and what to explain to you, you know. This should be hammered to you over 2 or 3 years, you know, particularly because they teach you OO concepts, and the first thing that you learn is public and private. And this is how we implement it in Oracle, by putting public stuff into the spec, and all this other stuff that's in the body is private. And everything has to be implemented in the body, and we generally create 2 files. Again, just like your procedures and functions, even if you create null, compile it, at least you got the thing running, and then you build it. Any questions?